All right, questions? Well, that was good. You got a private session at a very reasonable price. Do I have something with the cylinder? Couple. A couple. Cylinder is typically drawn like this. Conceptualizing. What they typically ask in a cylinder, there's a couple of different things. They're gonna ask. They ask the cylinder in a box. Okay, and that is how big is the box that fits over a cylinder, and that's using basically a circle in a can, circle inside a can. So sorry about that. That's one. Then they put balls in a cylinder. How many balls will fit in, or what's the area left over. And they also do the rate of a cylinder. This is the one that gets tricky, filling a cylinder, and this is the comparison. So they'll have two different cylinders, or they'll fill a cylinder at a certain rate and then ask you to compare it to filling a rectangular pool or something. So one of the questions could be, like a water tower is used to fill a rectangular pool. That's actually a pretty good question. Not too bad at this. Rectangular pool. If the tower is emptied at a certain vertical rate, the water's dropping down at a certain rate, how quickly is the water rising in the pool by volume? Well, that's a good question. I'm writing that one down. Or compare the volume of the cylinder to the size of the pool it could fill. What would be its dimensions? Those are the things. Conceptualizing them, the thing that you need to do is draw them. I wouldn't conceptualize a whole lot. I would draw cylinders and boxes. I call the three-dimensional problems here boxes, balls, and cans, because they use three-dimensional cubes or rectangular boxes, balls, spheres, and cylinders. Those are the three biggies, as well as a pyramid here and there, which then uses triangles. But if you can think of every possible way to put a box, a ball, and a can together, we put one inside of the other, and they'll paint surfaces, or they'll have volume misses. So surface area, volume, and emptying or filling are the things that they do with it. And they're relatively benign problems. They just intimidating because they're three-dimensional geometry, and most people don't ever deal with that. But the math themselves are the math itself is pretty easy. You got an example? I'll do one more for you. An example from Manhattan. I can even, since you're the only one. Yeah, go find one, and you can type it. You now have the ability to type on the board. So you can go right in here and select one of the tools and type the question right out. We'll draw it out and solve it. cylinder has a surface area of 360 pi. Love it. Can see where they're going right now. N is 3 units tall. What is the diameter of the cylinder's circular base or area? Alright, so it's going to be, just draw your can on your whiteboard. You're not going to do any better than me because your whiteboard's going to look like that. And it has a surface area of 360 pi. The surface area I like because what it has is the circumference of the circle times the circular top times the height of the cylinder is the label of the can. Okay? And the circles then have 2 times pi r squared. And that's surface area. It's not a formula that they give you. It's a formula that you have to intuitively derive. So the circumference of the bottom. So if I slid off the label of a can and I peeled it off, its length would be the circumference of the bottom and its height would be the height of the can. Then I have the surface area on the top and the bottom is equal to 2 times the surface area of the can. So the cylinder has a surface area of 360 pi. So this is going to equal 360 pi. I don't know why that does that. I'll work on that one. And it's a 3 units tall. So you can see where this is going. So this says 3 times the circumference. And what does circumference equal? So let's get one variable. Circumference is equal to 2 pi r. So I've got 3 times 2 pi r. And that's height times circumference plus 2 pi r squared equals to this 360 pi. I'm going to cancel out my pi's. I'm going to cancel out a 2. And I have a pretty interesting formula. I have r squared plus 3r minus 180 is equal to 0. Now